isolated commands, it doesn't make sense. But if you're sending more than systematic transmission.
We're looking at the flight control team do their job. So just trying to analyze our faces, you know. So as long as we don't see any ugly faces, we're good.
4 minutes, and then we will reconnect with the spacecraft after half an hour.
So Dietz is right there.
Just behind. It's cool, huh?
Oh yeah, actually it's right behind.
Yeah. And then it's coming. I think Dietz on the left side is coming.
It's weird to imagine.
What, the spacecraft is there?
Yeah, it's right there that I'm looking at it. It's weird.
Okay, not yet, but
Yeah,
in a few minutes.
Uh, 14. That's past the... there it is.
To speaker OM, we have EOS.
OM, Juice Bacon, we can confirm we have telemetry.
Copy.
Neuf, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage Vulcain. Allumage EAP, décollage.
One year in space and very busy. After launch we checked that the spacecraft and the payload were working nominally. And during the cruise phase we checked that the instruments are working normally. We check every 6 months.
Since the launch, there have been several operations ongoing with the payload in particular, because this is what we are really focusing on in the Science Operations Center. So we had the near-Earth commissioning phase with the instrument, so just checking that all the instruments were running smoothly. And this lasted for like 3 months. And then there have been some, let's say, more quiet phase in terms of payload activities, where the team has been starting to prepare the first payload checkout, which is an activity that takes place roughly twice a year, where we check one by one that all the payload instruments are actually performing nominally. So the first one took place in January this year. And the second one is about to happen in the beginning of July. So the first one went very smoothly, and so we spent the first part of, let's say, this year preparing for the second one that will take place now next week.
So you have to imagine that we have a suite of instruments, and they're all fighting for the resources of the spacecraft. They all want to do their science. They all want to use the scarce downlink capacity that we have. They all want to use the scarce power that we have as well in Jupiter. So we need to make up a timeline of activities and observations of the instruments. So the main task when we are around Jupiter and Ganymede will be to actually create these timelines in order to optimize the science return of the mission as much as possible and have everyone and every single scientist happy at the end.
The Jupiter tour is extremely complex, not only from a spacecraft operations point of view, but really from a science operations point of view. So there is a lot of constraints that will be there when we'll be at Jupiter. We have a limited power available, we have limited capacity to send data to Earth. We have also radiation constraints, we have pointing constraints. So all of this we need to think about it already now, so that we are ready when we arrive at Jupiter order to operate all those 10 instruments together. So we've been looking at where and how the science opportunities actually distribute over the tour and try to understand which science objectives should have priority along the entire duration of the tour. And based on this, we also check at a more detailed, refined level that the operations of the instrument to address the science objective are actually compliant with the constraints. So this is a very long and time-consuming activities. And more than anything, I think one very important aspect is that we need to learn to work together. Not only the Science Operations Centre, but the Mission Operations Centre in Darmstadt, and also all the individual instrument teams. So we need to learn how to make concession, because not all instruments will be able to work together at the same time. And this is something which is really a learning curve, which takes a long time. So I think the more than 8 years of cruise will be good for that.
So we're going to close to Cebreros, to the ESAC ground station, and which is in the middle of the countryside. And there we're gonna see the 35-meter dish of the main antenna in Cebreros. Okay.
Llame al timbre. I think I will have to go out of the car.
Yeah, they were expecting us, so I think...
Yeah, it's okay, they are opening the gate. As soon as we open the window, it's like...
This picture is about the ESA tracking station network, ESAC. Here currently we are in Cebreros ground station, which is part of this network. This is one of the deep space ground stations. The other ones are in New Norcia, here in Australia, and in March in Argentina.
It's also interesting to realize that it's really one of the part of the huge puzzle of the JUICE mission. So basically it's not only the Science Operations Centre, the Mission Operations Centre, but it's also here. I mean, everything also goes through here. So it's just the realization of what we think is theoretical is like the fact that JUICE is a huge mission which involves many, many groups and many, many places like this one.
We move files around, we work with digital products, and this is where actually those digital products become something physical. And there's, you know, in this digital signal that gets uplinked or downlinked, there's traces of the work that, you know, hundreds of people do, including us, and that's very nice. I think it's a very good reminder from time to time to, you know, get out of the box that we usually are in on our day-to-day routine work. We're gonna start receiving the monitoring camera images as well, and the NavCam images. So hoping that will go well. We looked at the times where we had the best opportunities to have the most interesting contextual images of the moon, because so the other cameras, the NavCam, the navigation camera, and Janus, the high-resolution camera, the resolution is so high, and we are restricted by how we can point the spacecraft in such a way that with the higher resolution cameras, we don't get a context of the flyby. We only see a tiny portion of the moon. It's like we see a tree in the forest. Whereas these monitoring cameras, they have a bigger field of view, and we see the context better. So we will be able to see almost the whole moon, also with a part of the spacecraft. So we're looking forward to seeing those.
Hello, and welcome to this live stream from the European Space Agency. My name is Josh, and I will be your host this evening. We're at ESA's European Space Operations Centre in Darmstadt, Germany, and we're excited to share the next roughly 30 minutes with you as our Jupiter Icy Moons Explorer spacecraft, or JUICE for short, flies past Earth's moon. It's returned to Earth this week to carry out the first of the gravity assist manoeuvres that will give it the boosts it needs to make the journey. But this isn't just any ordinary gravity assist. This is a special one. JUICE isn't just getting a boost from a planet, it's getting a double boost from a moon and then a planet, our moon and our planet Earth. Right now, as we speak, JUICE has just passed its closest point to the moon, and we have begun to downlink images that it took as it passed from our deep space antenna in Cebreros, Spain, not so far from Madrid. On the left of your screen, you'll see an animation that depicts where the JUICE spacecraft is at this moment. I'm joined this evening by Ignacio, the JUICE Spacecraft Operations Manager. Hi, Ignacio.
Hi, good evening, Josh.
Good evening. You work here at ESOC.
Indeed.
And you and your team fly JUICE.
I'm the leader of the flight control team,
yeah.
That's right. So I organize and coordinate the team that takes care of uplinking all the activities to the spacecraft, monitoring the telemetry, following up on the execution of all activities on board. That's right.
Cool, thank you. We also have Nico, the JUICE Mission Manager, with us this evening.
Yeah, hi everyone. So I'm Nicolas Altobelli. I'm working as a mission manager of JUICE. So this is a role when I try to take care of the entire mission and making sure that everyone can do his best job in the best conditions.
And finally, last but not least, we have Marc, who is one of the JUICE Science Operations Engineers.
Good evening, good afternoon, good morning, wherever you're watching this from. Yeah, thanks for the introduction. In our team, what we do is that we conduct science operations and we facilitate the instruments to reach their science objectives. And during the cruise phase, we're developing the systems that will end up implementing that during the nominal phase.
Cool, thank you very much. And thank you all for joining us this evening. Ignacio, I wonder if you could tell us a little bit about what the JUICE flight control team will be doing this evening, and then maybe also tomorrow evening as JUICE flies past Earth.
Okay, so the flight control team first task is to ensure that the spacecraft is safe and that it's able to perform all required activities. So during this phase, which is considered highly critical, the main purpose of the flight control team is to be ready to deal with any contingency and to react immediately. So we have been training for this event for months now, and we have developed special procedures, including very fast ways to recover the spacecraft, which are not the usual ways in which we would deal with a contingency, but rather accelerated timelines for contingency recovery that would allow us to bring the spacecraft back to a condition in which it would be ready, for example, to perform an emergency trajectory correction if it was necessary.
Yes, so we have the first JMC2 image on the screen, and so we still do not see the moon, which is expected for the acquisition time of this image. And what you can see here covering almost half of the image is the actual spacecraft. These are monitoring cameras. So their focus was to actually monitor the spacecraft. So half of what we will see in these images of JMC2 is actually the spacecraft. We got an update. So this is the first JMC1 image. As expected, it's also dark. And actually, I am not. No. We can actually see the moon already. Yeah, that's the first time that we can see the moon with JUICE.
So maybe Nico, if you could run us through the primary science objectives of JUICE at Jupiter and its mysterious icy moons.
Absolutely. So we are going back to Jupiter. So there were missions in the past going to Jupiter, but JUICE is actually the first one that will not only go to Jupiter, it will orbit Jupiter for a few years and then become the first orbiter of the icy moon, Ganymede. And that's the first time we have a man-made object that will be orbiting a moon which is not our own moon, the one that you're seeing tonight. And the main objective of JUICE in terms of science is, I would say, first to study the icy moon in their global context of the Jupiter environment. because what we want to understand is how those objects that are made of a mixture of ice and rocks could evolve in a way that is so different from one another, although they were born in the same conditions. And by sending a spacecraft there, we will be able to study at length with different instruments. We have 10 instruments on board. We'll be able to study the different aspects of how the moon are composed, what is their interior made of. At Ganymede, we'll be able to make a real tomography of the interior, and all this always in relationship with the rest of the environment, so to understand their evolution. I think we have nice images coming again.
Let's see what we got. It might either be an AFCAM or a GMC1. So as you can see, this is the next imaging sequence from what we had before. So we're seeing more of the moon, and I'm guessing that now images will be coming rapidly.
So what we see here is the last image that we managed to get down on the New Norcia station before handover to Cerberus.
Sort of getting overexposed. How if I removed it? It would look like that. So that's
no, that's TMC.
This is the one on the Z2. This is 2.
And that's 1. Sorry, and then.
So where is it? That one?
Yeah, this is the. Yeah. We've done 3 already. I mean, we already see in normal mode.
Yeah.
No critical events, nothing. There's only this thermal line, which is a bit cold. Very happy, very surprised also, because it went super well. Don't see anything. It's like a normal pass, and like nothing happened, really, seriously. No events, critical events, no failed commands, no out of limits. Behaved very well, like any other operation.
It's difficult to imagine a more complicated gravity assist, because we had everything. We had star tracker blindings, and we had an eclipse, and we had the moon occultation right before the closest approach, and the super tight navigation requirements. So everything was just stocked up, and in the end the spacecraft has been incredibly well behaved, super quiet, flying, super precise. So it's outstanding. I'm really happy with the results.
The overall flyby phase was about -1 month to +1 month with respect to the closest approach to Earth. So even though we see that we have very dense operation activities near the Moon, -1 hour to +1 hour, and then near Earth, so we started a few hours before closest approach, but actually operation extend up to 3 days, the instrument operations. And then we will still have an opportunity to look at the Earth and the Moon on the 9th of September, saying farewell until next time. And we will then officially close this phase around the 17th of September when we switch off the SSMM memory and we go back to cruise phase configuration until the next event.